In this video, I'll be explaining how optional data is managed using the option type. The option type is a type that may be one of two things. It may be some data of a specified type, or it may be nothing. It's used in scenarios where data may not be required or is unavailable at the time. Some examples are you're unable to find something, you may have run out of items in a list, or you may have a structure with forms and the forms aren't completely filled out. Before we dive into some examples, let's take a look at the definition of an option. The option type is part of the Rust programming library, and it is defined as an enumeration with two variants. The first variant is named sum, which represents some data. The second variant is named none, which represents no data. This syntax here may be familiar when we have worked with vectors. It simply states that option contains some type, and we don't know what type it is, so we use capital T as a placeholder. So this just reads, we have an enumeration named option, and it contains some data, and the data type is just some type of data. And the T is just a placeholder that can be used in the variance. And with the variance, for some data, we have associated information, which is a T. The T is just whatever type that was specified when you wrote the program. Let's take a look at an example so we can see how this works. Here we have a structure named customer. They have an age and an email. The age is optional data, and the data type, if they provide it, is a 32-bit integer, and the email is simply a string. So this structure may be used if they submit for an email newsletter and they didn't provide their age, for example. The first customer we have is named Mark, and they did provide their age. As we can see, they provided their age as sum, and then they have their age as 22. Normally with enumerations, we have to use the 2 colons along with the name of the enumeration and the variant in order to actually use the variant. However, options are so commonly used in Rust that the variants are exposed for usage directly without typing the word option each time. That's why we're able to just type in sum to represent the variants within the option. For Becky, she did not provide her age, so we place none as her age, and this will represent no data for Becky's age. Both also have emails, which must be provided. As we can see, it's a string. We have our string slices, and we change them into owned strings. To access data within an option, we can do so with a match expression. In this case, we're matching on Becky, and we're checking her age using .age. Both variants are accounted for, sum and none, which are the variants available in an option. So in the case where they did provide an age, I created a variable named age, and then if that occurs, we will print out the customer is blank years old as defined by the age. If no age is provided, no data, none, then we'll just print out the customer age not provided. In Becky's case, she did not provide an age. So when her age is matched here, this will not be executed. We will then match on none, and we'll print out that the customer age is not provided. Here's another example. We have a grocery item struct with a name and quantity. The name is simply a string and the quantity is an I32. We then have the function named findQuantity, which accepts the name of a grocery item as a string slice. It then returns optional data. The optional data returned is a 32-bit integer, which will represent the quantity of the item if we do find it at all. Within our function, we have some groceries made using a vector. We have 3 items, we have some bananas, eggs, and bread, and they each have a quantity. What we do in the function, we then check for a specific item as indicated by the name. We do so using the for loop, so for each item in the groceries, if the name of the item is equal to the name that we provided here in the function, then we're going to return some data. So this would be optional data, and it's returned as an I32. Since we have an I32 as the function signature return value. This word here is a Rust keyword, and it allows you to early return from a function. So far, we've just been implicitly returning at the end of functions and within our code. However, if you want to return early, you use the return keyword. I'm doing so in this case because if the user runs this function and they provide the name of bananas, we'll only need to go through this loop one time. So the first item will be bananas, we'll find it, and then we'll return the quantity. When we return, this function will just exit and we're done. Without this early return, I would have to go through every single grocery item, even though bananas was the very first one, and that's not very efficient. In the event that the user provides a name that's not in this grocery list, then we'll check each one, we'll discover that it wasn't found, so this will never be true, and then we'll just implicitly return none because we didn't find any grocery item with that name. Option is useful in this case because we'll find out if the grocery item is present at all in the list, and if so, we'll know how many of the quantity of that grocery item is present. To recap, option represents either some data or nothing. Some data is represented by the enum variant sum, and no data is represented by the enum variant none. It's useful when you need to work with optional data, such as form fields. And when you want to specify an optional data type within your struct or function, you use option and then the type name within the less than and greater than symbols.